My name is Tasneem. I'm the senior manager at 98 Percentile in the HR department. And today we did a wonderful drive with XLR. It was amazing right from the very beginning, from the very first day when I got in touch with them till today. I think it was an extremely smooth journey with them. There were multiple follow-ups done by the representatives in order to check that we would be, what time would be coming, how many people would be coming, what vehicle we would get. To that extent, they were so precise in giving all the information to us. It was extremely great to get associated with them and have a drive at XLR campus. So we are very, very happy that we got a chance to do this. Now, coming to the students, what XLR had, I think they were extremely enthusiastic. They were well prepared. They were aware of what they are coming for. I think there was some back-end preparation which they did that was commendable. They also were very confident and they were open to any kind of thing we were asking them to do. That was I think the best part. Now, I really hope we have a very, very fruitful association with each one of them and XLR in future. We are really looking forward to have many more drives like this.
Hi everyone, my name is Prachi Sharma and I'm the Senior Project Manager for IT Department at 90th Percentile. So today we were here for this IT bootcamp, right, this technical drive and at XLR. So it was a great experience and I would feel that the students, they are the freshers, right, but it doesn't seem like that. So if I talk about their technical and cognitive ability, they all seems pretty good in that and that's what I felt. And I guess they have been taught pretty well at XLR, so that's how they have performed good in their aptitude and the technical tests. So I wish them all the best and it was a very great experience over here.
Hi, this is Patan, Technology Consulting Manager from 98th Percentile. We visited XLR for the campus placement drive and it went very well today. Ms. Ambika, Ms. Pragati, everyone received us greatly here and we had a lot of enjoyable time here. The students even had great experience with us. They were interactive, they had good aptitude and all the technological skills they showed. I think they were all well and we really appreciate their time that they spared to us and I think we will be doing a great job. We are expecting a lot of people to be hired from them. Let's see. it was a great experience altogether.
Thank you.
Thank you so much.
From entering into this cyber tower to exiting out of this tower, the XLR team has been received me with such a care and pleasure.
I am the part of this XLR since 4 months. From the third month itself, they have conducted the placement sessions from the third month itself, and this is the fourth month, and this is the 98th percentile is one of the placement drive I have attended so far, and attending to this drive is such a good experience for me. All the HRs and the team made us feel very comfortable and confident.
XLR helped me a lot, and I experienced a lot of things today. So I'm really hope to be placed in that company. I'm confident about that. Thank you.
This was my first association with XLR. I had got a call from Miss Shubha, and we fixed a drive here. Today when we came here, I was not expecting much, but the hospitality was too good. Staff is quite cooperative, and it's like a happy-go-lucky kind of a environment here when it comes to XLR people. When it comes to candidates, yeah, we have got few candidates, and they are all agreeing to all our terms and conditions, and I hope they join the organization and work for us, and I'm expecting long-term association with XLR people, with more recruitments or more collaborations with them.
XLR has been a good partner for us because we found some of the candidates were excellent, and we wanted people with good business experience, not only just the Java or whatever full stack development or whatever they were being trained on. They were also people with a good background knowledge, and whom we have really shortlisted, and we assume that they are going to make a good career in BusyBrains.
XLR arranged our placements for the BusyBrains company. I felt good. I hope that it will be positive for us and change our lives in IT sector. So thank you, XLR.
Hi, my name is Revant. I joined XLR's course of data analytics. While the course was going through, the faculty were very good. They were guiding us really well, and they were providing in-depth insights of the industry. We were taught the latest things. We were taught what the industry needs, and after that, post completion of my course, we were going through a live project where we were facing real-time scenarios, and we were encountering all those scenarios which we would be encountering in a job. We completed the project, and we got through a certification which stated that we got a data analytics certification from XLR, and after that we were placed in mock interviews, and they also gave us how the interviews are and how tough they are. The interviews were really good, and post completion of the mock interview they started placement drives. Today is my first placement drive in a company called Busy Brain. I really want to thank XLR for providing me this opportunity, and I'm really hoping to see much more opportunities in the future. Thank you, XLR.
When I came into XLR, the learning experience was very good. Today there was the interview session from Busy Brain's company. The interview session went extremely well. I got to learn many new things. Thank you, XLR.
My name is Almas. So I'm here to do a campus drive. I'm coming from a company called Dotline. I deal with HR and operations. And unexpectedly, I got a call from Ashwin sir. So he was saying about XLR solutions and the way he approached us, saying that the candidates will be trained as per our requirements. So digital marketing was the immediate requirement. We have gone through the interview process. It was quite excited to see good number of talent pools in XLR. We could shortlist couple of them, and we have given some placements as well, even both for the full-time as well as internship. So overall, our experience with XLR is nice, and we look forward for a long-term relationship with XLR and the excited team. Thank you.
Hi, my name is Rupesh, and I work with Dotline as a performance marketeer, and I've got about like 15 plus years of experience. So today I happen to come here for the placement drive. Rightfully matched few profiles based on the requirement that we had. I'm so happy that XLR did a great job in terms of getting the pool of talents out and training them, and lucky that we are here so that we got the right match and we were able to get it. And thank you so much, XLR. Thank you.
So hello guys, myself Mohammad Tarheeb. I am a graduate from aviation background, and then I thought of doing my course in digital marketing. So then XLR was the best opportunity for me. I took out digital marketing from them, and then I enhanced my skills in digital marketing. They offered me a campus drive in a company called Dotline. They gave us 3 days of good session for student development program, wherein they gave us a good opportunity of learning whatever the skills is required for the interview, for us to enhance our skills and then perform well in interview. So yeah, after the interview went well and I have got selected in Dotline Designs right now, and I am excited for the opportunity coming up.
Hi, I am Pinky. I did my MBA in HR. How I got to know about this institute is through Google. And then we got a wonderful trainer whose name is Asar. He used to give theoretical ideas, and for this interview, we had a prior 3-day session for just brushing up all the requirements needed to attend the interview, which is again a wonderful thing from XLR team. So I had a good experience in attending the interview session for Dotline company. Thank you.
My name is Rahul Ulkar. I'm been working as a senior architect in UV systems. So today we are here at XLR Systems for the placement drive, and I really appreciate the placement services that the team that I actually met. We really got a good service and hospitality service actually. The way they actually welcome is really fantastic, and I love this is actually one of the best experience that I have ever. And and about the student quality, today we had interviews with almost like 25 to 30 students, but the candidates are really good. I mean, with respect to knowledge, with respect to communication, I mean, they are much more familiar about the technologies. Most of the interviews we had in Java, and the students are really fantastic. Thank you.
I'm Hariprasad Bugate. So today we have come here on the behalf of Urix Systems, and so we are conducting a drive at XLR. The students here, they are also, we found them very confident. Thank you.
Hello everyone. My name is Mayuri Pimple. I have completed my full stack development course from the XLR EdTech Private Limited. The XLR is doing the fantastic job. The XLR placement team is doing the excellent work, and they are also providing the SDP session that boost our confidence at the next level. I would like to thank the whole training and placement team of the XLR for arranging the drive at the XLR Pune office. Thank you. The training provided by the XLR was very fantastic. The placement was provided are also good. There are the various SDP sessions was conducted at XLR office, so that student can enhance their skill and knowledge and crack the interview and boost our knowledge to the next level.
The training provided by XLR is flawless. They provide good placement support. They doing STP sessions regularly to boost our confidence to the next level. I would like to thank whole XLR team to arrange the campus drive at Pune office.
Hi, myself Sudhakar. I came from People Link Unified Communications, and there I am working as a head for the marketing department. Today we visited this XLR for campus placement drive. So we are happy that we came here to XLR, and whoever we interviewed today, we are very much happy because they have very good knowledge, not only theory, and we can see they have like a good practical knowledge also. They are providing very good strong foundation for the candidates. So we are planning to hire more people from XLR.
Myself Mohammad Khalib, and I'm from People Link. Like I'm a digital marketer of the People Link. We came for the XLR to take an interviews of the SEO and other like digital marketing interviews process. So about the XLR candidates, the profiles, like we got shortlisted. Like if they have a good knowledge on the digital marketing. So apart from digital marketing, they have on marketing other activities like customer support wise or any other like so here we got a good candidates. So more SEO part or the social media marketing or the PPC. So like the interview process like was good, and we actually got a good candidates here. So we have taken like more and more candidates from the XLR.
Good afternoon, everyone. I'm Mohammad Siddiq, and I've done my digital marketing course from XLR Solutions, the best learning platform for digital marketing. It's XLR Solutions. What specialized solutions what I have studied in XLR is SMM, social media optimization, social media marketing, SEO, search engine optimization, and etc. The service and the learning platform and the tutors was excellent, and they have provided me a best internship platform with People Link. It was very pleased to have that opportunity to me to explore my skills and execute my knowledge on that platform. Thank you so much.
Hello, myself Sucharita. Recently I have done my digital marketing in XLR, and since digital marketing is the most trending and evolving platform in the market, you can often career here in this field. So in XLR they will provide you intense training and in digital marketing, and the trainer are very well trained and they have good hand-on experience in digital marketing. So they will provide you each and every details and train you perfectly in the field of digital marketing, and after the completion of course they will provide you to work in real field in projects, so to elevate your knowledge and skills in digital marketing. After completion of course also XLR has provided placement assistance for me. Today I have come here to attend a placement interview conducted by XLR in People Link company. So my experience in that job interview is very good. The HR are very good and friendly. They have explained you very well like in which field and how the digital marketing works in their company. So till now I have a very good experience in XLR, and I definitely will recommend you to join the course for your future. Thank you.
Hello guys, myself Nikhil Reddy. I'm currently graduated with Masters in Management with Sales and Marketing. I'm currently done with my interview and I've done my digital marketing course with XLR. I found the course online in Google in top ranking in search, and based on the curriculum and everything, and the professors and everyone are quite excellent in the XLR team, faculty team. And my professor was Mr. Uday, and Uday was a Google certified and Google trained professor. He teaches me digital marketing, and during the classes he was an excellent professor. He used to clarify every doubts, and if I had any doubts post the class period, he used to personally take care in teachers and clarify the doubts. today I'm here with people, selling people, interviewing for them, and my interview went well good, hoping for the good. Thank you, XLR.
Hi, myself Rohan. I have completed my degree, and after completing my degree, I decided to do digital marketing. And through internet, I have got this XLR solutions, which has number of ratings. So I decided to join. So after completing, I even did projects, live projects. They helped me in each and everything. After doing that, they even placed me in interviews. And today I attended People Link Company. Thank you, XLR.
Yes, so the collaboration with XLR was an excellent one. We conducted a Power BI workshop with Advanced Excel over a span of 3 days. The workshop was almost 12 hours long in total. Mr. Karthik, who was an amazing trainer, helped the students understand the concepts deeply. I am sure that the students will be able to apply these concepts in their careers as well as their daily lives.
The trainer, Mr. Karthik, was an excellent person where he explained in very detailed manner on how to give great insights using very complex data sets.
So it was a machine learning workshop. We learned a lot from the course, and it was a great experience attending the workshop.
The trainer was very helpful. He had a hands-on approach with his teaching, and it was fabulous.
This was a great experience for me. So I would absolutely love it if XLR and its team would come again to our campus and conduct more events like this.
It was a great course, and it started from basics and took me to a great extent.
The experience of the workshop was really nice. The feedback from all the students was positive. They understood the concept. The workshop was also practical based with some questions. The experience with XLR was very smooth. They helped us in conducting the workshop smoothly, right from the booking of the vendor and deciding the course till the distribution of certificates. In overall, this workshop was a success during our technical fest Atmos, and I thank XLR for being a part of it.
was very much interested in learning digital marketing course for a very long period of time, but I don't get a proper platform. So later from our college, I get to know about XLR and I enrolled in XLR course. It was really good experience. Our course has been taken by Mayur sir, and he was very good teacher. He not only focusing on theory part, he is doing how real digital marketing works, and it was in total very good experience. I get so much of knowledge. Here they're not only focusing on study, they're also conducting different exams to test our knowledge. And as we are giving the exam, so to appreciate our work, they give certificates for the toppers, and along with the certificate they give hampers. Thank you, XLR.
Recently, I was searching for digital marketing courses online in Google, and I came across XLR, and I attended a digital marketing course which was for 15 days. My mentor Mayur helped me for attending these classes. So he is a very informative and helpful guy. In the course end, there is a exam which I topped, so I came to the XLR office in Bengaluru. This digital marketing course has helped my career and my skills to develop, and the certificate has helped my company to join. Thank you, XLR.
I came to know about this course from my college. Actually, for learning platform, this is very nice, and I learned from here ChatGPT and AI from online. Vikas is teaching for me for AI generative and ChatGPT. We are using this technology in more. And after finishing the courses, I came for collecting the certificate. I seen the classrooms and faculties. Classroom is very nice. After the completion of exam, they will give gift and certificates. Thank you, XLR, for giving these courses. I learned a lot from this. I gained the more knowledge from here. And thank you for XLR for teaching us.
Hello guys, I'm Vikram Mahajan and I'm studying in Swami Vivekananda Institute of Technology College, and I came across a training program which was mobile app development using Flutter, which was given to us by XLR Solutions. I came across this program through my college faculty who told us about this program, that it is a very good course and you should enroll in this course. So I enrolled in this course, and initially I felt really good about this course because they started everything from a very basic point of view, that even if someone who doesn't know anything about Flutter or anything about mobile app development can also learn the same way the ones who know about it are learning. So no student was left behind and everyone was given equal attention. All the doubts throughout the course were cleared. And if we had any questions also, we were like, the trainer was also ready to stay for a longer time than it was scheduled, even for the sake of doubts. So that shows how important the students are to them. So it was a really good experience with XLR's program, and by the end of the training program, I was able to develop my own application. And through the development also, there was another point. So our sir taught us about how we can connect our own mobile phone to our laptop and write code in our laptop, and you can see the output in your phone, which is really creative and interesting for me. I felt really good about that. So in the end, I developed my own mobile application. I showed it to my mother, I showed it to my friends. I felt really good about it. So I would really suggest XLR. I would recommend it to all my friends to take courses from here, as they focus on the children, focus on the students, and they focus on what's necessary, that is the students' doubts gets cleared and everything else. So today I came down to the XLR office to collect my certificate. So I got to know about what other courses XLR is offering. It included data analysis, data analyst, social media marketing, and full stack Java, and many more courses which were interesting, and they gave us an insight of how everything happens, and they take you through the course from the starting of the course to the end, and what next, that is placements as well. How you should be going into the interviews and how you should be approaching to companies, your resume building, and there were so many things which XLR is going to help you in, and they are ready to give you all the knowledge required even if you are a beginner. So I really felt good about this visit, and I would really recommend XLR to everyone who's listening to this, and also to all my friends, that I had a very good experience with XLR, and I would suggest you to experience the same. Thank you.
Hello everyone, my name is Satish and I am from Swami Vivekananda Institute of Technology. I am here to share my experience about XLR program. I took part in the XLR program that was conducted in the last month about the mobile app development using Flutter. What I liked the most about this session was the trainer started from the scratch. That means even the beginner who don't know about the basics of the program, even they can learn the most from this program. It gave me hands-on experience by developing a project which was the final outcome. Thank you XLR for giving me this opportunity, and I would also recommend all my friends to take part in the XLR programs. Thank you.
Yes, so the collaboration with XLR was an excellent one. We conducted a Power BI workshop with Advanced Excel over a span of 3 days. The workshop was almost 12 hours long in total. Mr. Karthik, who was an amazing trainer, helped the students understand the concepts deeply. I am sure that the students will be able to apply these concepts in their careers as well as their daily lives.
The trainer, Mr. Karthik, was an excellent person, where he explained in very detailed manner on how to give great insights using very complex data sets.
So it was a machine learning workshop. We learned a lot from the course, and it was a great experience attending the workshop.
The trainer was very helpful. He had a hands-on approach with his teaching, and it was fabulous.
This was a great experience for me. So I would absolutely love it if XLR and its team would come again to our campus and conduct more events like this.
It was a great course, and it started from basics and took me to a great extent.
The experience of the workshop was really nice. The feedback from all the students was positive. They understood the concept. The workshop was also practical based with some questions. The experience with XLR was very smooth. They helped us in conducting the workshop smoothly right from the booking of the vendor and deciding the course till the distribution of certificates. In overall, this workshop was a success during our technical fest Atmos, and I thank XLR for being a part of it.
I was very much interested in learning digital marketing course for a very long period of time, but I don't get a proper platform. So later from our college, I get to know about XLR and I enrolled in XLR course. It was really good experience. Our course has been taken by Mayur sir, and he was very good teacher. He not only focusing on theory part, he is doing how real digital marketing works. And it was in total very good experience. I get so much of knowledge. Here they're not only focusing on study, they're also conducting different exams to test our knowledge. And as we are giving the exam, so to appreciate our work, they give certificates for the toppers, and along with the certificate, they give hampers. Thank you, Excella.
Recently, I was searching for digital marketing courses online in Google, and I came across XLR, and I attended a digital marketing course which was for 15 days. My mentor Mayur helped me for attending these classes. So he is a very informative and helpful guy. In the course end, there is a exam which I topped. So I came to the XLR office in Bengaluru. This digital marketing course has helped my career and my skills to develop, and the certificate has helped my company to join. Thank you, XLR.
I came to know about this course from my college. Actually, for learning platform, this is very nice, and I learned from here ChatGPT and AI from online. Vikas is teaching for me for AI generative and ChatGPT. We are using this technology in more. And after finishing the courses, I came from for collecting the certificate. I seen the classrooms and faculties. Classroom is very nice. After the completion of exam, they will give gift and certificates. Thank you, XLR, for giving these courses. I learned a lot of from this. I gained the more knowledge from here. And thank you for XL for teaching us.
Hello guys, I'm Vikram Mahajan and I'm studying in Swami Vivekananda Institute of Technology College, and I came across a training program which was mobile app development using Flutter, which was given to us by XLR Solutions. I came across this program through my college faculty who told us about this program, that it is a very good course and you should enroll in this course. So I enrolled in this course, and initially I felt really good about this course because they started everything from a very basic point of view, that even if someone who doesn't know anything about Flutter or anything about mobile app development can also learn the same way the ones who know about it are learning. So no student was left behind and everyone was given equal attention. All the doubts throughout the course were cleared. And if we had any questions also, we were like, the trainer was also ready to stay for a longer time than it was scheduled, even for the sake of doubts. So that shows how important the students are to them. So it was a really good experience with XLR's program, and by the end of the training program, I was able to develop my own application. And through the development also, there was another point. So our sir taught us about how we can connect our own mobile phone to our laptop and write code in our laptop, and you can see the output in your phone, which was really creative and interesting for me. I felt really good about that. So in the end, I developed my own mobile application. I showed it to my mother, I showed it to my friends. I felt really good about it. So I would really suggest XLR.
Hello everyone. Please let me know if you can hear me. You can, if you can hear me, just raise your hand or just drop a message in the chat. Hello, can anyone hear me? Yeah, thank you. It seems like I'm audible. So, welcome all of you to this session. So, can you tell me? I mean, before we start the session, I would like to understand, what you know about this particular data science and ML. I know that you are trying to look for career in this particular field. So, can you guys? I mean, you can type and I mean, what else, I mean, how much do you know about this particular machine learning, data science, and AI? Or you can unmute yourself and you can just tell me what is the level you are right now, so that I will try to explain. I mean, I will try to plan these 5 day sessions to ensure that you know what happens in industry in this particular field, and at the same time, what I need to explain you are what are the types of projects which I can deliver to you, so that that will be helpful for you in preparing for your interviews, or while creating your reports in git, so that your profile will be highlighted, or creating your profile in linkedin, which will make you stand out from other candidates. So can you just drop me what I mean, like, just like do you have an idea about what AI is, what ML is, and what data science is? Or you are new to even that concepts, or you have an idea of, you have been working on this particular this AI related projects so far? Can anyone like unmute? I mean, I think you are all part of any session or class. You can message me if you are not comfortable in speaking.
Yes, sir. You're clearly audible and your screen is also visible.
Okay, so I just need one confirmation. Do everyone have idea about what is AI, what is ML, and what is deep learning, and what is data science so far? Or do I need to explain what all these concepts are?
You can give the introduction, sir.
Yeah, sure. So yeah, as I already told you, so welcome to this session. And the focus of this session will be to introduce to different projects. I mean, different projects that were being handled in industry in relation to AI and ML. So coming to AI is an wide topic, and which encloses machine learning, deep learning, data science, reinforcement learning, and there are different things which are part of artificial intelligence. When it comes to my machine learning and deep learning, these form a subset of artificial intelligence. So artificial intelligence is nothing but we try to mimic, I mean, we try to make machines to mimic human. Like for example, you might have been using iPhones or Google phones, I mean Android phones, where you have been using this Siri application or Google Assistant, which tries to respond to the question you have been asking. So this the backend model that's being operated by this particular application will be an AI model. Or if you have been using Amazon or Flipkart or Mintra or any shopping website, you might, or even Netflix or Amazon Prime, you might have seen some. I mean, based on your purchasing pattern, you might have been observing some recommendations from the application. The backend algorithm which happens beside this behind these particular recommendations is a machine learning model or a deep learning model. It can be either machine learning model or deep learning model, which will try to predict your pattern of try to understand your pattern of purchases, and then try to recommend the closest options which meet the patterns which were learned by the model based upon your shopping history or your viewing history. So this is these are some of the examples that you might have been exposed to without your knowledge. And there are various applications in machine learning, like for example, let's take in particularly in healthcare industry, there are multiple models being trained to predict if a person goes into an operation theater, whether what is the likelihood probability that the particular operation will be successful, or the probability that a particular patient will die, or will meet an unfortunate death, or what is the probability that there will be some complications related to this particular surgery, or if given a drug to a particular patient with some genetic history, what is the probability that that particular drug will have highest effectiveness to treat the particular disease. Or let's take this in when it comes to financial applications, you might have frequently heard about this credit card default prediction application, or based on certain features of the customer, you can try to predict whether that particular transaction or that particular user is a fraud transaction or fraud user or not. Or based upon various features related to an application, the model can predict whether the particular application is an fraudulent app or an genuine app. Or you can even try to predict, provide recommendation systems based upon hidden patterns of a person's browsing history. Or even you can try to predict prices of any particular good or services based upon historical trend or based upon certain factors. Or even you can try to predict what could be an energy consumption in a particular area, provided that this is the growth of that particular area. Or you can even try to predict what will be efficiency of a particular efficiency of a particular machine, or provided some features, you can even tell, or you can even predict what is the likelihood chance of this particular machine going into predictive maintenance in near future, or what could be the expected data of predictive maintenance for that particular machine, provided this is the operating data, or this is the sound data, or any other kind of data that is available with us. So there are multiple thousands of applications that are happening within industry, even in like in manufacturing industry, or in advertisement industry. Even in advertisement industry, there are use cases which we have worked, like what is the effective revenue that will be generated if this particular product or service is promoted using this particular medium or this type of promotional activity. So we try to build models to understand the features, are the features which impact our target variable. Like for example, in this case of advertisement, our target variable will be the revenue that can be generated from an advertisement. So we try to predict what are the major features that are impacting our target variable, and try to predict what would be the expected revenue that can be generated from that particular advertisement, or what will be the expected value of a target, provided these are the features that we are going to use to train the model. Anyone, any questions so far? I will take that as a no. So yeah, this I had explained. So this is kind of an image which depicts how these AI, ML, and deep learning are related. So artificial is nothing but we try to simulate human intelligence in machines, and machine learning is nothing but we use data to identify, to train a model which identifies hidden patterns which we cannot see, and try to build an linear, some equation, or it can be linear or non-linear equation, or it can be an tree-based model, or it can be an hyperplane which separates which separates that data points. It tries to predict that particular information. It tries to understand that particular information so that that information can be used to make future predictions on unseen data. And when it comes to deep learning, deep learning is sub part of machine learning, where this algorithm tries to mimic human brain. Like what happens is, like if you remember your school biology, there will be in human brain, there will be neurons which are connected to other neurons through an communication network, where this particular neuron will send an information which will go through complex interactions, and then passes the information to next level of neurons, which in turn will process the information to next level information based on complex interactions. So similarly, in deep learning as well, we have input neurons which try to connect with the next layer of neurons, where in the first level of neurons will understand one part of the information, which passes that information augmented with the learnings from the data in that particular neuron, and then passes to the next layer of the neuron, so that this learned information is passed to next level, and in the next level it tries to understand higher level features and higher level information and then pass it to next layer. So this is how this deep learning algorithm try to mimic this particular human brain and then try to make predictions. So my plan is to work. I mean, we have 5 days. So my plan is to have different types of project, and each day today we'll be dealing with regression problem, and tomorrow we'll be dealing with classification problem, and if possible we'll be dealing with forecasting problem as well. And after that, I will try to introduce this deep learning algorithm as well, because with the launch of large language models, majority of focus is on deep learning techniques. So I would love to have, I want you to have an understanding about how this deep learning and neural networks work, so that you will be prepared to deal with these kind of problem statements in future. So for this one, we'll try to solve an natural language processing problem statement using deep learning, neural networks. If possible, we try to solve an computer vision problem. We'll take small problem and try to solve that one using convolutional neural networks as well. And and if time permits, I will give you a basic idea about what these language models are, and what is the trend that is happening, and how they are being used, and what are the solutions that are being built, and what are the concepts or terms you need to know, and so that you will have an idea about this particular large language models as well. So this is my plan. So today we'll be dealing with regression, and tomorrow we'll be dealing with classification, and if possible, we'll deal with forecasting. If we are unable to deal with forecasting, we'll take forecasting and clustering on another day. So that we'll take 2 days for this deep learning, both NLP and computer vision. So that, and during the computer vision itself, we will try to use. I will try to explain these large language models as well. So if anyone wants anything else, just drop me a message here. So yeah, any questions so far? You have any questions related to any of the concept, any of the terms I mentioned so far, or you want me to make any changes to my plan? Okay, I'll take that as a no, because there's no message. So coming to some of the key concepts, I'm taking that you don't have much idea related to AI and MS. That's why I'm explaining these basic concepts as well. So when we say AI or ML or deep learning, there are three types of, majorly there are three types of machine learning algorithms. One is supervised learning algorithm, and the second one is unsupervised learning algorithm, and third one is reinforcement learning algorithm. Our major focus will be on supervised and unsupervised learning. So when it comes to supervised learning, what we have is like we'll be having some data, and we already have a labeled output. That means we have the features data and we have the target variable as well. So in target variable, we are using this available target information and the features information to try to find out how this target information is being impacted by the features data which we have. So we are asking it to understand based on the information we are providing, and we are providing supervision through provision of features data as well as target variable data. Like for example, if you want to predict something like if a particular machine will go into maintenance or not, initially we will try to provide some features data, like this was the number of hours the machine was operating, and this is the frequency of sound that was emitting at the point of time before the particular machine went into maintenance, and whether the machine went into maintenance or not, and the maintenance date. So if the maintenance date is target variable, we try to understand how this maintenance date is being impacted by the features which we are providing. Or if you are predicting price of an good or price of an house, we try to understand different how the different features are impacting the target variable. Or if it comes to classification, if a person gets a disease or not based on his lifestyle, we can use the features data, and we also provide whether he was impacted with the disease or not, so that it tries to understand how this particular target variable is being impacted from the data, from with the variations in data, so that it will learn what are the patterns behind this features data that are impacting whether a person is getting impacted by the disease or not. So this is how supervised learning happens. And when it comes to supervised machine learning, there are two types of problem statements. One, in industry, mostly these are the two types of machine learning problems in supervised learning. One is classification, and another one is regression. Regression is a problem statement which we deal with when the target variable is a continuous variable. Continuous variable in the sense like there is no limit of value for that particular target variable. Like for example, if you say if you take house price prediction target variable, we are trying to predict what could be an house price. So the house price can be anywhere. Like for example, it might start from 10 lakhs to 20 lakhs to 30 lakhs. It can even go up to 1 crore, 2 crore, 3 crore, 4 crore. I mean, it can. There's. I mean, ideally, infinity is the value it can go. I mean, even though there is no infinity and you can't go beyond certain level, but still it can have any number of any type, any value within this particular range. For example, it can be 1 crore 10 lakhs, 1 crore 11 lakhs, even 1 crore 10 lakhs and 25,000. It is like a continuous variable. So if you have a continuous variable as your target, then it will be a regression problem statement. Like you can have like for example, if you see this image here, some of the examples for population growth are like what could be population growth, or you can try to predict forecasting, or you can do market forecasting, like you can do stock market prediction. I mean, don't do that one particularly because so far none of the model worked effectively to predict ideal stock market prices, so never do that one. And like estimating the life expectancy, or predicting price of a good, or predicting price of a service, or predicting what could be output in a particular manufacturing process, or what could be lifespan of a particular person, or what could be the number of hours a particular machine will run. So all these are regression problem statements. And when it comes to classification statements, we have only limited number of choices. Like for example, let's say we are predicting if a person will get a disease or not. So in that case, what happens is like we have only two options: whether he will get a disease or he will not get a disease. So we can segment the people into either getting a disease class or not getting the disease class. So classification will be like, will be having very limited number of classes, which we try to predict in which class the particular patient will fall. Like, I mean, this can be multiple. It's not like it should be only two classes. It can be multiple classes. Like for example, when it's two classes, we say that as binary classification. When it's multiple classes, like more than two classes, we say it multi-level classification. So what happens is like if you say let's say what can be the yeah, let's say sentiment analysis. I mean, even though if you're given a text, you need to predict if the sentiment is positive, negative, or neutral. So we have three classes here, and we are trying to predict, given this particular text, can we classify this particular text into a positive sentiment, or negative sentiment, or and neutral sentiment. So this comes into three classification problem. So depending upon number of classes you want to segment, like even if you take this flower classification, they can be you might have seen this iris flower data set, where we have four classes to predict. Given certain features of an flower, can this flower be this fall into this particular class, another class 1, or class 2, or class 3, or class 4? So there will be different classes of different classes when we are dealing with multi-level classification. So some of the examples related to classification are fraud detection, image classifications, customer churn prediction, and disease diagnosis. And we can even try to identify if a particular patient falls into a particular gene class or not. So there are different types of classification problems, and that are being dealt in industry. And apart from this supervised learning algorithm, another major problem statements which we deal with is unsupervised learning algorithm. In unsupervised learning algorithms, we'll be dealing with clustering techniques and dimensional reduction techniques. And this particular dimensional reduction techniques are being used as feature engineering or feature selection techniques to reduce the number of features for classification problems, or regression problems, or clustering problems. This dimensional reduction can itself be a problem statement, or it can be an intermediate step while dealing with other machine learning problems as well. And coming to clustering, this is where we try to segregate different data points into different clusters. So we try to identify hidden patterns which make a group of data points together, or which separate data points together, so that we can create clusters of different data points that are available to us. And so in clustering, we'll be dealing with customer segmentations. Like when we have some customer data, we try to identify whether the particular customer will fall into a particular class or particular cluster or not. And then we try to use this cluster algorithm to targeted marketing, because we in advertising we try to find out what kind of advertising is right for a particular cluster of people. So through that we try to optimize the revenue. And as I already mentioned, this recommended systems as well will use this clustering algorithms. And another one, an important one, is reinforcement learning. So in reinforcement learning, what happens is we try to make, I mean, this kind of unsupervised learning, but more advanced unsupervised learning, where we try to we try to make the algorithm to learn what should be the next step based on reward or punishment. Like if it takes the right step, then there will be a reward given to the algorithm, or if it takes a wrong step, there will be a punishment, so that the particular model will try to understand what next step should be. And through this it tries to understand hidden patterns. And through this it will be able to it will be able to mimic the human made decision process. So that's why this reinforcement learning is kind of more advanced to when compared with supervised and unsupervised learning. So any questions so far? Okay. So, yeah, I mean, I guess these terms are already explained. So, we'll be using training data to train the model, and testing data to test the model, and evaluation metrics to evaluate a particular model, how well the model is performing. And the target, as I already mentioned, target is our target variable which we want to predict. And features will be the other feature data points which we are trying to use to make the machine learn how the target is being impacted. So, coming to regression problem statement, I mean, today we'll be discussing the regression problem. And this is an supervised machine learning algorithm where we try to predict an continuous outcome variable based upon our input features. As I already mentioned, you like predicting house prices, or predicting in price of a good, or predicting making stock price predictions, or predicting how a commodity price moves. So all this comes into, or maybe a lifespan of a particular patient. So all these problem statements come into regression problem statement. And it will regression will help us in understanding the relation between variables. At the same time, it will help us in understanding relationship between the variables and the target variable, so that we can understand the impact between the relation between our feature variable and our target variable, and how that particular this feature is impacting the target variable in what way. So this is how we use regression. And there are multiple types of regression techniques, like simple linear regression technique, where we you might have seen in our mathematics classes in our school, where we use y is equal to mx plus c equation in linear algebra. So you can see in the image to the right side, I mean, we used here theta 1 plus theta 2x, because in linear regression our main goal is to predict these coefficients, theta 1, theta 2, theta 3, theta 4. Here it's a simple equation. That's why we are using y is equal to theta 1 plus theta 2x. But when it comes to real life examples, what happens is like the equation will be like y is equal to theta 1 plus theta 2x plus theta 2 x1, where x1 is one of the feature variable, and theta 2 x2, where x2 is another feature variable. If x1 to xn, x1, x2, x3, x4, x5, like that, 2 up to xn are the feature variables which we are having and which we are using to train the model. And if theta 1 and theta 2 up to theta n are the related coefficients to the feature variables, we try to find out these coefficients to fit the equation y is equal to theta 1 plus theta 2 x1 plus theta 3 x3 up to theta n xn, depending upon number of features which we have, and try to identify the coefficients which will create a line that fits the data points here. If you can see, can you see my cursor moving? Okay, so if you see the data point, the red data points here, these are our training data. And what we're trying to find is, we are trying to find a line. So we are trying to find a line which will fit the data so well, so that our error, which we are trying, which our error is minimized. Like the error is nothing but what is the predicted value here. Yi is the predicted value, and y is our actual value for that particular data point. So what we are trying to do here is we are trying to minimize the value for yi minus y. That means for every data point we calculate the error and we try to minimize the summation of this error so that we get the coefficients in such a way that this particular line will try to pass through all the data points in such a way that the error between majority of the data points are all the data summation of all the summation of errors of all the data points is minimal. So that's our goal while doing linear regression. So this is how we do linear regression. Anyone have any questions related to this image or how linear regression operates? And by the way, this theta one is nothing but m or slope, sorry, intercept, c or intercept in our y is equal to mx plus c equation. So this will try to find out what do you call like the error which we cannot reduce. Anyone have any questions? You can drop a message in the chat. No, yes, okay. So whenever we try to solve an machine learning or data science problem, there are multiple steps which we follow. So as soon as we define first thing is we need to first define the problem statement. Let's take I will take one of the problem statement which we try to solve. So we were working with a client where they wanted to understand given data of a particular customer. This was a business to business customer. So they were selling a product to a customer business to a business, and we have certain features like what is the business type, the way I mean, what is the type of business, and there are multiple features. And there is another set of features where the salesperson has communicated with the particular business contact person, and there will be multiple calls that will happen. During the time period. So he tried to initially they will try to do through emailing, cold calling, and then they will try to connect with the decision maker through phone calls, and they will directly visit the consumer and they will try to explain about the product. And every time they will collect feedback and they will try to find out what the response will be and how frequently the particular consumer is responding. So all these data points were there, and our ideal goal was to predict if given this sets of information about that particular customer, will he turn into business or not? That means will we get business from that particular customer or not, provided these are the what do you call that the attributes of the particular person, a particular business decision maker. So we had thousands of features, and we worked on building a model. I mean, even though that's an classification problem. So what happens is like when we get this, I mean, when we get a client, we try to understand the problem first, and in some cases even we don't know what the target variable is, because right now I'm telling you this is the target variable, but what happens in real time real life problem is sometimes you don't know what the target variable is, and you need to understand the target variable from the data, because the customer is sitting on the data and he doesn't know what to do with the data. We need to try and see what the data is, and we need to come up with an problem statement that defines the data, and that will help the particular customer to use that utilize the data to make right business decisions. So what happens, the first step will be to define the problem statement accurately as much as possible. So we need to identify what is the data that we are going to use and what is the target variable which we are going to predict. So this is what the definition of problem statement, and we need to define the target variable in such a way that what is being expected from the model. Like are we going to treat this problem as a regression problem, or are we going to treat this as a classification problem, or totally we are dealing this as a cluster problem or clustering algorithm. So what happens is like first we need see it's not like for every target variable the data, I mean, you might see the data as continuous for target variable, but still in I have seen some problem statements where that continuous target variable is converted into classification algorithm, and then that is used as a problem classification algorithm, that is used defined as an classification problem statement. And in some cases this continuous variable or these classes were converted into clusters which were used just a second guys, just give me a second. So yeah, sorry for that. So we had continuous variable and classes classification variables, but still that problem was converted into an clustering algorithm. So we need to understand the problem statement effectively, and then based on that information, we need to define our problem statement. Because in one of our problem statement, even though our target variable was continuous, when we trained the model, the model was not fitting effectively. But when we converted the problem into an classification problem, we were able to predict the classes effectively, and the problem the business problem was successfully solved, and it received like major appreciation from the customer as well. And because I'm telling you this because even the customer doesn't know whether the problem has to be a regression problem or the classification problem or to be an clustering problem. So we need to identify, we need to understand the data, we need to come up with an best approach to deal with the problems. I mean, it's not like all the cases it will be like this. In some cases they will be clear understanding or clear information about what is the target and what they're expecting from you. But in some cases this happens, so you need to be ready for this one as well. So the first step is defining the problem statement. Once you are designed once you define the problem statement, the rest will be easy because you are a data scientist and you already know what to do with the data. So that's the first and major important problem is defining the problem statement correctly. And once you do that one, the next thing that comes is data. You need to get the data. Where is the data source, and what are all the data I need to use? Because in most of the case, what happens is like data will not be in single database. We need to take data from different databases and bring that to a point, and then use that data to train your model. So you need to identify what the data, right kind of data that needs to be used to for your model, and you need to collect that data, and you need to bring all the data source and data from different data sources to a single data point, and then use that to train the model. So second important thing is dealing with the data and collecting the data. And the third important thing is pre-processing the data. Here there will be like in some cases in some organizations, what happens is like there will be data engineering people who will be dealing with collection of data and pre-processing our data, where they will build ETL pipelines. But in some cases, or most of the cases, a data scientist should know all these things, even though he might not work on ETL pipelines on day-to-day basis. But it's good to have that information, and it's good to have that skill to deal with this data, because you are the right person to understand what type of data do you need, and what type of processing that needs to be applied, and what kind of data. So the third and most important step is pre-processing data. If you do these three steps effectively, training model is it will become very easy for you. So when it comes to an life of a data scientist or an ML engineer, data scientist or ML engineer, they spend most of the time in dealing with the first three steps, and the next time they spend will be on training and evaluating and deploying the models. So the first three steps are more important, and that three steps will define decide the success. I mean, will have most say in success or effectiveness of your model. So the fourth step is training your model, and we train different algorithms. We use different models to train the model, and try to find out which model is fitting effectively the data, and then we use the best models, and we do hyperparameter tuning, we do cross validation to identify the right hyperparameters for the particular best model, and use that best model, and we evaluate the model on different metrics. And even here, so once you train the model, then becomes evaluation of model, because until unless you evaluate you give the best model, and you know the model is best, you can't give that to the consumer. That means you need to know if the particular model which you are training is effective or not. So in order to decide that one, we evaluate the model, and we use different metrics for different problem statement. Like for example, when it comes to regression problem statement, we use mean absolute error, mean squared error. I mean, you might have heard like MAE, MSC, or R square, or adjusted R square, or MAPE. Different metrics are available depending upon your problem statements, or depending upon your use case, and depending upon your requirement. You will be using different metrics to evaluate your model. And sometimes even customer will ask you like, use this, but my criteria is this particular metric. Like for example, he will say like, I want adjusted score to be the best, so you need to evaluate model on adjusted R square. Or they might say like, my criteria is mean squared error. So you use mean squared error to evaluate the model. Then you have to use mean squared error to evaluate the model and decide which model is best. And then once you evaluate and once you decide the best model, there are two ways to do this one. One, if you can download the model coefficients and you can deploy that one using a different application. Like for example, you can use Fast API to deploy the model, or there is AWS or Azure or GCP services which provide you different options to deploy your models, and then that model will be deployed into some interface, and you can create an UI on top of that one. Like for example, you might have heard about Chainlit or Streamlit or Fast API, or different other options are there. You can use any of them, and then try to give an user interface to user, and then they will use unused data on top of that one, and they will interpret the data or predict use the data to make predictions on top of unseen data. So this is how a typical life cycle of and data science problem looks like. And again, once you deploy the model, there is one more step, and one of the important step is that a concept called drift. It's called model drift or data drift. I mean, it can happen. Like for example, when you train a model, the data might be distributed across some data range, and what happens is like because of time change or because of over the period, what happens is like data will shift slightly from one data range to other data range. So what happens is like the model that the model understood the data patterns when it was into a certain range, and now the data shifted to another certain range, which it will not be able to predict effectively. So then you need to retrain the model. So to identify if my model will is if there is any drift in my particular data or in my target variable. Let's say, for example, few years back, the price of a particular car is at most the car prices mid-scale car ranges were from up to 25 lakhs or 30 lakhs. But with inflation, what happens is like the price will keep on increasing, and after 10 years the price range will be, price range will be will start from 25 lakhs to 50 lakhs. But the model which we trained was trained when the price ranges was from 10 lakhs to 20 lakhs. So ideally the model is not suitable to make predictions on top of that one, because the maximum value it was observing was 25 lakhs, but now the minimum value is 25 lakhs and maximum value is 50 lakhs. So in order to deal with this one, we need to identify if our model is suited for the current latest data or not. If we find a drift, then what we have to do is we need to retrain the model and redeploy the model, so that the model is up to date with the data. So this is one of the other important thing. This comes into model monitoring, and we need to continuously monitor the model. There are different techniques to monitor the model and identify if there is a a drift detector or not. So this is an ideal data life science cycle. So the first step will be data. When it comes to model training and model building, the first step will be data pre-processing. Once we do data pre-processing, we try to understand features. So that's where we do exploratory data analysis. EDA means exploratory data analysis, to understand how the data, every data or every feature within the data is distributed, or how it is varying. And if required, we try to do feature engineering. Like for example, there will be different features all pointing towards one thing, but they have different way in representing the feature. So what we do is we try to club them, or we try to find out a way to represent all those features in a single feature. So that's a kind of feature engineering which we try depending upon the data. So this you will understand when you have the data, and when you try to see different features in different ways. So that's where this EDI will help us, and feature engineering will have an important role in deciding the performance. One of the important role in deciding the performance of our algorithm. And then we select the algorithm based upon how we try every algorithm, and then we try to predict. We try to evaluate the model and fix upon a particular algorithm. And remember this statement: it's not like you will always go with the best the algorithm which gives you the best metrics. Like for example, r square of 1 is the best value in general. So r square value varies from 0 to 1. So when we are evaluating a model, we try to maximize the r square value, and we try, if it's not like we always look at r square of 1, and if there are two algorithms where a complex algorithm is having r square of 1, and another non-complex and simple algorithm with r square value of 0.85, in most of the the data scientists or most of the customers will prefer the non-complex algorithm with 0.8 or 0.85 as R square rather than they go for R square of 1 because complex algorithms will come with I mean there will be some dependency issues or there will be some complications that will arise because of from these complex algorithms, and at the same time it's not just the metrics, it is also the explaining the explainability of the algorithm. Like for example, you might stack 10 or 20 algorithms and make you can make R square up to 0.99. But the problem is you will not be able to explain why that prediction is like that. Why the model is predicting the value in that particular I mean, why the particular value is being predicted as that particular value by the model. If you don't explain that particular prediction, then it can our model is just like a prediction algorithm and doesn't solve the business problems effectively. This is the most important thing you need to remember: model explainability. So most of you will face this issue, and you might probably face some questions related to this model explainability. If you are taking notes, then note this model explainability. This will be one of the important questions which they will ask you in your interviews. So what ideally we are trying to do is we are trying to okay, it's 8:30. Okay, we have one more. So yeah. So we are trying to explain why the prediction is like that, so that and which feature is impacting how much. So that what happens is, like for example, let's say this person is will face this particular disease, like some X disease. So there are X1 to X9 features, and we say the particular patient is being screened for a disease called D1, and the model predicted this particular patient will get the disease. So we are trying to see which particular feature impacted the person to get the disease. If we know the feature that impacted the particular person to get the disease, and if we know the value of feature, like for example, if a particular person smokes regularly, which is causing the I mean, if you see the data, if you see the predictions, and if you see the particular all the patients who are smoking are facing heart disease within the age of 60 to 70, then we know that there is highest risk category of smoking for that particular age group, and then we can tell them that okay, if you continue this one, you are more likely to face this issue, or you can, if you stop this one, you can probably be on safer side. So we need to come up with that kind of explanations, and our algorithm, the model which we train, should be in a position to explain the predictions. So then the model will have the highest value and highest visibility. So that's one important thing, and it's not about always not about the metrics. So it's our own thought process as well. We need to look at the model, we need to look at the metrics, we need to look at how well we are explaining the predictions. So it's not just like coding. You need to understand the business problem, and you need to understand what is happening throughout the process. Then you will be able to solve the problem effectively. So once you do the algorithm selection, you go for training and you evaluate, and then you do the hyperparameter tuning, and then once you do the hyperparameter tuning, once you decide the best hyperparameters, you further retrain the model, and then you repeat this one until you reach the effective scale, or you get effective performance. Then you use the model to deploy. So that's how the process looks like. So any questions so far on anything? I guess no questions, and I hope you understood this explainability and all these concepts. Yeah. So now let's go with the major purpose. So we wanted to have the project. So let's start with one of the problem statement. So I took this data of let me restart my session here in Colab. So for this entire session, what we will be doing is we will be using Google's Colab, which is free for use. If you have your Gmail account, then you can create a Google Colab. So if you are opening your laptops, or if you are attending from session, you can open your Google Colab and try and see that one, so that you will have an idea how to use that one. And one more thing is, if you want to work on GPUs also, Google Colab will provide you free GPUs, but in limited with limited performance. So that will be sufficient for you to build your notebooks. So you can use that one. So we'll be using Colab notebook to solve these problem statements, which I mentioned earlier. So yeah, let me share my screen. If you have any questions, you can drop a message.
Sunil sir, if you're talking, you're on mute. Can you please unmute yourself?
First, how long I was on mute?
So, like, whenever we started, no? So 10, I think 10 minutes.
Okay, so that's a mistake. So yeah, you understand about Google Colab? Sorry, I was sorry for that. I thought I was speaking to you.
Yeah,
Okay,
no problem.
I'm my
So just please
mistakes.
respond still at what time you are hearing, sir.
Sorry, I didn't get you.
No, I'm just asking students to reply on that, like till what time you are able to hear.
Can anyone mention a last thing which you heard? Did anyone heard about explainability, model explainability? Can someone please message if you are if you heard about? I mean, if you heard me explaining about model explainability because that's important thing. No, okay, sorry for that, and I will start with model explainability because that's one more important thing. Yeah, so let me go to the presentation once again, and because I don't want you to miss that, and you might face a lot of questions related to that one. So here, as I think one more question. Did you understand till pre-processing the data? Pre-processing a training model, evaluating model. Yes, okay. So the problem is, it's not like every time we focus upon the metrics alone. Because let's say we are building, let's say this particular problem I faced, I had a model which is complex model. For example, I used multi-stack model. Like for example, I stack 10 models and can give you the best performance. Like for example, R square value from 0 to R square value ranges from 0 to 1 in general, and ideal case the model should have highest R square value. So let's take 1 as the best, 0.99 as the best metric which we are trying to reach. Let's say I have a stacked ensemble model where I have 10 algorithms stacked on one on top of other, and I have another which is giving me an R square value of around 0.98, and there is another simple algorithm which is giving me an matrix of R square value of 0.8. So what happens in this case is, any data scientist, I mean, most of the data scientists or most of the customers will be ready to use the simple model with 0.8 R square value as the final model rather than going with a complex stacked ensemble model, which is giving the best metrics. Because what happens is, our major problem is not just the particular metrics alone. We need to explain why that particular prediction is like that. What we are trying to do is we are trying to understand why the prediction the why the model is predicting that particular value for that particular data point. Because if we know this one, we can adjust the data points so that we can reach our target goal. Let's say for example, there are some features with us and we are trying to predict energy consumption of a particular locality or a particular house, and we have certain features or particular categories of features with us. And if there is a category, there is a feature which is when the particular feature is present within a certain range, or which when has some value to allocated to it, will make higher energy consumption, then we try to focus on that particular feature and we try to bring that feature into a value which will reduce the power consumption. So ideally what we are trying to do is not to just make the prediction, we also want to understand what is influencing the prediction so that we can interact with the feature that is influencing the prediction, and then try to make changes to that one so that we can reduce the risk, or we can ensure our business decisions based upon this particular information. So that's what the industry looks at. Like for example, let's say we are trying to predict let's say we are trying to doing a predictive maintenance for for a car or for a machine. So we have some sound data, or we have some car features that are running maybe some how many kilometers it was running, and what type of roads it was running, and the GPS route map, and the fuel consumption, and how many kilometers it was running, and there are multiple other features as well. And we are trying to predict what is the next date or next target date, or what will be the number of days between two maintenance activities. So our main goal is to reduce to increase the number of days between two maintenance activities, because for every maintenance we need to spend more amount of money. So if we want to, we're trying to predict what will be the number of days before next maintenance activity, and we are using these features. And we found that the GPS the route the particular person travels is impacting is impacting this particular the target variable, which is number of days before which the next maintenance activity happens, in such a way that if the particular person travels in a route, the number of days will reduce, and if a particular person travels in another route, the number of days will increase. So our ideal case will be to increase the number of days. So what we can inform is like, we can tell him like this particular vehicle has to travel in this route, so that the frequency of maintenance will can be reduced, and we can increase the lifespan of the particular vehicle. Let's take this problem statement. I mean, this might look simple in case of car, but let's think in terms of logistics and warehousing and logistics case. So we are using multiple. They might be using multiple trucks, and they need to optimize the cost that is associated with the travel cost, right? So if they follow a route, maybe they can increase the number of kilometers, but because the road is good, or maybe they are because of other climatic factors or other factors, that particular route is trying to increase the number of days between maintenance activities. Then probably we can tell the customer like, if you follow this route, you can reduce the cost of maintenance. That means obviously we are not just predicting the maintenance activity, we are also giving the information what is the feature that is impacting the number of days before this maintenance, and how we can help them in reducing the cost of maintenance. So this is what is more important, and model explainability will be easy when the algorithm is simple algorithm. When we have complex algorithms or stacked and simple algorithms, what happens is like, the way we need to explain the prediction will become difficult. So always remember that it's not just the metrics alone, it depends upon the problem, and it's also models explainability. And recently, models explainability is gaining more importance, and you need to have more focus on that one, and try to understand more about this model explainability. There are different concepts like feature importances, sharp values, lime, and there are multiple concepts which will try to explain why that particular prediction is like that, and what are the factors that are influencing the prediction. So yeah, that I wanted to have. I wanted you to have this understanding. That's why I repeated this one, and I'm sorry for wasting your time speaking on mute. Let's go to our problem. So now this is Colab, and for next 5 days we'll be using Colab. And if you're comfortable with PyCharm or VS Studio also, you can use VS Studio and PyCharm to do the same thing. And IDE which we'll be using here is Jupyter Notebooks. And because I and to explain, it will be comfortable because we can see what is the output for each step. So that's why I'm using Jupyter Notebooks, and the data I'm using is from this UCA institution, and the data has this information. So we are trying to predict the mileage of the particular car, provided the information about this particular car. So we have car make and model, and we have number of cylinders, and we have what is the displacement, and what is the horsepower, what is the weight of the car, and what is the acceleration, and what is the model year, and what is the origin. And our target variable here is mpg. If you look at this one, this is a continuous target variable, and as this is the continuous target variable, we are trying to predict this. We are making this problem statement as a regression problem statement. So generally, we have to, when this data is stored in a database, we need to call this data based upon this methods provided by the particular institution. But I just wanted you to show you how to load a data on your own and use that one. That's why I downloaded it and then loaded that file into here, and using this path you can see here, you can copy the path from here, and when um, you can provide the path of where the data is located, and you can use the method from pandas to load the data. So starting with this initial one, so the first step which we need to do is we need to use different libraries. there are multiple libraries that are majorly used. I mean, they're majorly used by data science and machine learning. They are like Pandas, NumPy, Matplotlib, Seaborn, Scikit-learn, TensorFlow, PyTorch, and these are the most important libraries. And there are other libraries as well which we will be using depending upon your requirement. For example, we'll use Sharp for model explainability, and there are other libraries as well. So pandas and numpys are libraries used to perform data operations on top of data or data frames, and matplotlib and seaborn are for visualization. There is another library called the plotly, which will help you in creating 3D visualizations for your particular data, to visualize your data in 3D. And scikit-learn will provide you with different methods and functions and algorithms as well, where you don't need to write your own functions for every algorithm, and all these functions all these algorithms are already defined, and we will call them, and we will be using these algorithms, and we will train our model using scikit-learn's model algorithms. And yeah, so initially, so this is called a cell within the Jupyter notebook, if you guys don't know that one. And to run this cell, you can either click on this run play button, or you can keep your cursor within this cell and you can press on shift enter, so that it will automatically run the cell. So now by running this one, we are already loading the data, and we are using calling this pandas library as pd and numpy as np, and using methods and functions that are available in that library within this Jupyter notebook. So now I am calling read underscore csv method from that particular pandas library, and to load the data and create a data frame for that particular data. So here my file is CSV, so that's why I'm using read underscore CSV method. If your file is Excel, you'll be using read underscore Excel. If it's Paraket, it will be read underscore Paraket. If it's JSON, read underscore JSON. There are multiple ways to, multiple methods to load different types of files. Depending upon your type of file, you will be using that particular method. You can get that information from Pandas library based upon your data type. So once you to create a data frame, you'll be using this read underscore CSV, or whatever the, depending upon your file, you can use the read underscore CSV or read underscore paragraph kind of methods. And I'm creating this data frame df. So if you look at this one, so this is my data frame, and these are my features. This all these horizontal columns, vertical columns are my features, and mpg is my target variable. So now I have my data frame here, and I can perform actions on top of this data frame. Now going to this df underscore head method will show us like, but this is generally used to see, to have an basic glimpse about data. It will generally display 5 rows. If you want to increase the number of rows, you can add the number of rows you want, and you can run the cell. So it will display 10. If you want to display 20 rows, you can display 20 rows. Depending upon your requirement, you can change that one. And there is another method called tail. So what happens is like, it will show the bottommost values from that particular data set. So you can data frame. So you can see we have total 397. You can see the bottommost 20 values are being displayed to you. So this is how this tail and head work. So to understand what is the data, we have an method called info in Panda. So we'll use that one. It will provide us like what is, it provide us with a lot of information about the particular data frame or the data. So data frame is nothing but we are loading the data into data frame. So I will be using data frame to refer to the data. So here you can look at the data frame here. So total we have 9 columns. That means our total number of columns are 9. That means we have 8 features and 1 target variable. And it will also provide us like what is the, for each column, what is the number of rows, total number of data points we have, that means total number of rows, and how many non-null values. That means non-null means there will be null values within the data frame. And another important thing I wanted to mention is the data will always not be as clean as you see. So there will be data with lot of missing values, or null means missing values, and there will be data like NAs, NAMs, NANs, and there will be some what do you call unexpected data values. Like for example, in a continuous data, you might see some categorical data values as well. So first thing is you need to pre-process the data. So to understand how the data frame, how the data is, we use this info method to see. Like for example, you can see like car name here is an object data type, and we can see that obviously car name is an object data type because it's categorical data, and cylinder is supposed to be an int data, and we can see it's integer data. Sometimes what happens is like even though you can see the values of 8, 9, 3 kind of numbers, still the value is represented in object type. So, and another important thing you need to remember is like our machine learning models will not be able to detect this object data type, so they need to be converted into numerical format to be able to use in training the model. So that's why we need to understand what kind of data type is there in that particular feature, and is it the right way to represent that one. For example, if let's say the cylinders data type is being represented as object here, but if we look at here it is integer, that means it's not representing it correctly. So we need to first convert that into numeric data. We need to convert this cell into this column into numeric so that it will be correctly represented within that particular data type. And it will also provide us with how many null values are there. That means if there are any null values, or if there are any non values, or if there are any NAs, all this information will be provided from DF info. And there is another function method called describe, which will provide us a glimpse about how the data is distributed, and this will be displayed only for numerical data points. So you can see here car name is an object, and you can't see the car name in this particular matrix here. So it will provide us like how many data points are there, what is the mean value, how the data is distributed, what is the standard deviation, and what is the 25th percentile, what is the 75th percentile, and you can understand. It will give a glimpse of how the data is varying here. And then once we understand the data, as I already mentioned you, the first and foremost important thing is pre-processing the data, because if you have your data clean, and if you have your data clean and if your data is effective, then training the model will be very easy, because machine learning models can't understand categorical data, and machine learning not all the machine learning algorithms, but some of the most of the machine learning algorithms will not be able to deal with null values or nan values. And if let's say for example your target variable is a continuous target variable, but because of some human error or because of some ETL error, the data that comes into that one is some categorical value. What happens is like the entire column will convert into object data type, and machine learning will algorithm will thinks like it's an categorical data, and it will throw an error. So before starting training, we need to pre-process the data and ensure that data is in such a way that the model, the algorithm can understand the data, and it will be trained effectively. So in order to do that one, we need to perform various pre-processing activities like cleaning the data, encoding the data, and do feature analysis and perform feature engineering, and we can even do feature selection as well, and visualize the data to understand if the particular we need to find out correlation as well. I mean, because if you see some of the algorithms, if there is correlation between different features, then what happens is like because of this correlation, it might the model will get overfit, and it might not be able to predict effectively. I mean, even though it will give you the best metrics, it will not be able to predict effectively in unseen data. So in order to deal with this one, we need to first understand the data and ensure the data is represented effectively, so that that data is rightly suitable for training the algorithm. So in order to, in this case, what what we are going to do is we are going to clean the data, and we are going to encode data, because actually we can drop this car name column because that doesn't have any significance, but I just kept it because I wanted to show you how to do encoding. So going to the next step, the first thing I'm doing here is encoding. So here I'm using label encoder to encode this particular value. Here encoding is nothing. I mean, what I'm doing here is I'm assigning a value to this one. For let's say, for example, let me take you value counts of this one so that it will be easy for you. I'm not beyond the time, right? I have 30 more minutes. This value counts will provide you with how many different types of values are there and what is the actual number of this particular case. So here you can see there are around 305 rows. That means 305 different types of values are there. Ideally, for this case, this particular encoding is not suitable, but still, to explain you, I'm keeping this one. So let's take, we have only four models. Let's take Ford, Toyota, Chevrolet, and AMC. If we say that we have only four types of values within this car name column, then what we can do is like we can create four columns for individual value. Like for example, I can create a column for Ford, I can create a column for Toyota, I can create a column for AMC, and I can create a column for Chevrolet by dropping this car name column. And if this particular cell contains Ford here, let's say if this contains Chevrolet here, so what happens is like there will be one more column, there will be four columns here with the name Chevrolet, Ford, AMC, and Toyota, and the value for Chevrolet will be 1, and for rest of the three columns, Ford, AMC, and Toyota, it will be 0. And when it comes to AMC, for this cell, what happens is like for Ford it will be 0, for Toyota it will be 0, for Chevrolet it will be 0, but for AMC it will be 1. So through that, we are making this categorical data into an numerical data. Or we can also do another thing, like for example, let's take we have colors, I mean red color, red, blue, green, and we can assign numbers like 1. I mean, like we can assign numbers to this one, like we can assign 1 to Chevrolet, we can assign 2 to Ford, we can assign 3 to AMC, and 4 to Ford, and we can use that as a feature column. Instead of using this categorical, I mean this string data, we can use assign some number to that one, and we can use that number. But the problem that you will face is, as we know that 1 will have always have a less number of value than 2, and 2 will have less number of value than 3, and 3 has less number of value than 4. We are inducing an hierarchy within this one by giving and by assigning numbers. So that's why when there is no hierarchy within the data, you should never go with assigning random numbers to that one. Instead, you can go with one hot encoding, so that you can create different columns for each categorical value within that particular feature, and that will ideally represent that feature itself. So you can either do label encoding or one hot encoding, but the preferred one is one hot encoding when you don't have any hierarchical information. But let's take heights, like for example, medium height, less height, medium height, and tall height. We can use hierarchical information here. Instead of creating one hot encoding, we can do label encoding here and give 1, 2, 3 to these heights based upon less. For less height, will give 1. For medium height, will give 2. For high tall persons, will give 3. So that what happens is like there is hierarchy, and we are capturing that hierarchical information through our label encoding. So that's how you need to do encoding based upon your own decision here. So you need to understand whether we need to use label encoding or one hot encoding, depending upon the type of information that is there in that particular categorical feature, and based upon that, you need to encode the data so that that particular categorical information is converted into numerical data, and the algorithm can understand that information. So this particular step will convert the particular categorical feature into numerical information, and then the label will be given into, that will be transformed into and numerical values here. So now you can see here, as I told you, right, one hot encoding. You can see here car Volvo, the car Volvo 244DL, car Volvo 245. It will create number of columns. I mean, it will create that many number of columns based upon that many number of value counts that happens within that are available within that particular categorical data. You can see that one hot encoded values here. So if that particular value is present in that column, then it will be true, or else it will be false here. So that's how we do one hot encoding. And the another important thing is dealing with missing values. So this is the step where we deal with missing value. First, we need to understand how many missing values are there, and in which column, which features is having these missing values. So if you run this cell, you can see that, ignore this heat map. I thought like we will capture that information from heat map, but only one feature is having this null values. That's why you can see only this particular feature is having this color change, and rest of the column doesn't have any gradient change here. So you can see that only horsepower has null values here, and that particular column has around 6 null values here. And then we know that now we need to deal with this particular horsepower to deal with these null values. Before dealing with that one, let's try to understand how each feature is distributed, and how let's try to see how different features are, to understand the features and how they are distributed. So this particular function will try to plot each feature. They will provide an KDE plot to it. It will provide us distribution across the range, and it will give us an visual understanding of how the features are being represented within this data. So if you, it will take some time because it has to plot all the plots. So this is distribution for our target variable. You can see that majority of our data points are represented across this particular 15 to 25 miles per gallon, and there are very few data points related to 45 gallons per hour and 40 gallons per hour. And most of the data points, most of the cars has the range within 13 to 35 miles per gallon. So we can, this is what kind of information we can derive from this one. And if you want to know why we, I mean, how it can help us, you can know, you know that we can convert this problem statement to classification problem statement, right? So you can use this bins to convert into a classification problem and use that information to convert them. So you can also understand how the data points, the other features are also distributed across this ranges using these distribution plots. So this is how different data points are, I mean, the features are distributed across this. And these are now, these are pair plots, like how two features are interrelated with each other. So this provides you information about how two features are either correlated or not, and this is the information you can get from this particular feature. And you can also use correlation heat map. You can see like all these features are correlated, and it can, you can understand how much this correlation is. Like you can see like this displacement is having highest correlation with cylinders, and we know that this particular displacement feature is being impacted by cylinders. So through this, we can understand which features are being impacted by which features, and use that information to do feature engineering here. And when it comes to the feature, how each feature is impacting our target variable, we use this plot to understand these plots to understand how our target variable is being impacted with each feature. And I'm not going through these plots. I will give you this notebook. You can go through that one because I think it's late and we need to go to the particular target training of the model. So now what I'm doing is, and again, this is also visualization plots for you. You can understand this visualizations based upon how different features are being distributed across the data ranges. And as I already told you, now we need to deal with imputation. So now we have missing values in horsepower. So we need to deal with that one. And I'm providing you with different types of imputation techniques. I provide notes for different types of imputations and when to use which imputation technique. So with, I mean, depending upon your data, you need to impute, use different types of imputation techniques. So in, when it comes to continuous data, we prefer median imputation, and when it comes to categorical data, we prefer mode imputation. And if you don't want to do imputation, you can try to predict that the missing value using the information that is available with us, and then use that predicted value as imputation by using algorithms like k nearest neighbors and all. So I mean, I will try to explain this one in next sessions when we deal with classification and all. And so now we go with imputation here. So what I'm doing is I'm using the simple imputer method from sklearn, and using median as my strategy. You can change this to mean, or you can change this to mode depending upon your understanding of the problem. You can change the method you are going to use to impute that one. And once you impute that one, there won't be null values. That can be visible from here. You can see we had 6 null values in our horsepower. Now you can see that there are 0 null values from our horsepower feature. So now the data is clean, and now we can train our model. So now what I'm doing here is I'm using multiple different types of regression algorithms here. I'm creating a dictionary of different algorithms like linear regression, ridge regression, lasso, decision trees, random forest, support vector regressor, XGBoost regressor, and I'm trying to use all these regression algorithms and trying to find out which one will give me the best results. Because right now our focus is not on explainability. We'll go with explainability as well as we progress towards in the next sessions. So right now my focus is on metrics alone. So I will be focusing only, I will be training my deciding the best model based upon the metrics. Here what I'm trying to, so if you look at this particular code piece, what we're trying to do is for every model in this particular model, for every model in this dictionary, algorithm dictionary, we are running the iteration and we are using the same training data, and we are trying to understand we're trying to register our mean squared error value for each training, for each algorithm, and then trying to print out what is the means value for that particular value. So here, if you look at this one, for linear regression algorithm, we are having highest MSE. That means we are having highest mean squared error value for linear regression, and the least value is for random forest. Mean square error is nothing but the value of the difference between the predicted value and actual value squared value of mean value of summation of these y minus y hat values, and our goal is to minimize that value. So we need to identify algorithm which has the least value for that one. And if we look at this algorithm, we are finding that random forest regressor is having the least value of MSC algorithm, and that is our metric. And you can change the metric here to R square value or mean absolute error or adjusted R square depending upon your requirement. So, and I gave you different types of metrics, which will, I mean, what is meaning of the particular error value, I mean, metric value, and how it will be helpful, and when then can be used, so that it will give an idea about what to use when. And so, go through this notes; it will be of helpful for you. So here we know that random forest is working better. Now we need to perform identify what are the best hyperparameters for this particular random forest algorithm. Now we will be doing this hyperparameter tuning here. So for the best model, we are trying to use we are using. So this is we are displaying the best model name here, and we are creating an dictionary of parameters for different these best algorithms, and we are performing hyperparameter tuning for each algorithm here. So for performing hyperparameter tuning, that means we are identifying the best hyperparameters for that particular algorithm. Like for example, when you take random forest is a tree-based algorithm, and there will be different hyperparameters which will decide the performance of that particular random forest algorithm. So for that, get that best hyperparameters, we need to understand, we need to identify for which parameter set this particular algorithm is giving the best metric. So that's why what happens is like we are creating grids. For example, if you see here random for random forest, we are using two hyperparameters. We are not using all the hyperparameters here. We are using only two hyperparameters. One is number of estimators, that means number of decision trees which need to be used to build the random forest, and what is the maximum depth it has to go through. And so we are limited. We are giving it to 5, 10, and for number of estimators, we are giving 5, 50, 100, and 200, and it will bring up with the best combination of these two values for random forest for the given data to make the best MSC value and displays the best values for this particular hyperparameters. So if you look at this one, we have, so we don't need maximum depth, and we need to remove this maximum depth because based upon grid search CV, we are able to identify that we need to leave that up to it, and it has to go to the maximum depth, and the number of estimators we need to use the best number of estimators is 100 here. That means we need to use the combination of 100 as number of estimators and maximum depth as none. Then when we use these two values as hyperparameters for random forest, we will be able to achieve the best results. So that's what happens in case of grid search HV. There is another method also to perform this particular hyperparameter tuning, which is called as random search CV. In case of random search CV, what happens is we will be using all the combinations. And I mean, instead of in grid search CV, we will be using all the combinations. Like for example, let's take we have three elements for n number of estimators and three elements for maximum depth. So what grid search CV does is it will create combinations of 50 none, 55, 50 10, 100 none, 105, 110, 200 none, 205, 210. So it will create all the combinations, and it will train the model for all these combinations and then decides which model is best. But when it comes to random such cross validation algorithm, what it does is that it will select random, like it will take 50 and 5, I will take 100 and none, and whenever it finds the best value, it will display that one, and it will use that value as the best algorithm and use that parameters as best hyperparameters. So we'll be dealing with this one in classification as well. I will try to show you how this grid search CV and random search CV will work. And now the time comes to train the model, and we already trained the model, and we already have the best hyperparameters for the model. Now what we are trying to do is we are trying to predict predict the model on unseen data, which we kept aside for our testing the data. So initially, what we did is we used our data, we split the data into train and test data set, so that we use only train data to train the algorithm, and so that the algorithm doesn't hasn't seen the information within the test data, but we already have the target variable here as well, and it will compare how I'm doing. Like for example, in test data, it hasn't gone through that features. So when the data is passed to the algorithm, it will try to predict a value, and we already have the value with us, and it will check, okay, how I am performing on unseen data, and based on that, now it will try to come up with the best value for this unseen data for the test data. So our ideal goal is to maximize the metrics for this particular test data, and that's what we are doing here. And now you can see the best values for this particular test data is 4.0204. That means, I mean, if you have seen that particular train data, it was comparatively different when it comes to test data, because it hasn't seen the test data so far. That's why it is there's a lot of chance that it might not be able to predict such in so much effectiveness like it predicted for train data. So now we'll in the next step we are trying to visualize our best fit line, because ideally what we are doing is we are trying to predict the coefficients, this theta 1 and theta 2, theta 3, and all these coefficients, which will decide the predictions, or which will be helpful in making the predictions. So we need to understand how well our best fit line is able to predict the data points. So that's where we plot this data, and we can see that this is the best fit line which we were able to detect from our training, and these are the data points from the data set. So now we can see like it is processing across all the data, and we can see like, okay, this model is working effectively because it is able to understand the patterns within the data, and the data is fitting the data well, and the line is passing through the data effectively. So now we can understand like, okay, the model is working effectively here, and now we can use the model. And what will we do now is like we will download the coefficients, or we create a pickle file of this particular trained model, and use that pickle file or job file to deploy the model into the application, and we create an app on top of that one, so that these coefficients will be fixed, and if any new data comes into picture, that data will use these coefficients, and then train that tries to predict the model based upon the value it calculates from these coefficients. So any questions so far? Today I had to explain about basic concepts, so I didn't spend most time on training. So tomorrow, while dealing with classification, I will try to show you each part of what happens within this training, different steps of training the model. Like why do we need to use particular like for example, why we are using mean, why are using mean imputation, why do we need to use median imputation, why do we need to use mode imputation, when to use predictive imputation, and then I will show you why this what happens when we don't convert this null, we don't do this imputation, and what happens when we don't create this do this convert this categorical features into numerical data. And instead of writing all these steps, what we can do is like we can create a pipeline, and we can pass our data through the pipeline, which is ideally the case which will be used in industry use cases. So we'll be working upon creating the pipelines as well, so that we define the functions, and then we create a pipeline using the function, so that data automatically will pass through all the steps, and then goes to the predictions finally, or goes to the training finally. And I will also explain about different algorithms like linear algorithms and ensemble algorithms and tree-based algorithms, so that if you need to have an idea about how an algorithm works, because you don't you need to understand what the hyper if you need to understand what the hyperparameters are, you need to understand what the algorithm is and how the algorithm works. I will give you a basic glimpse about each algorithm, I mean at least basic and important algorithms, so that you have an idea about how that algorithm works and what are the hyperparameters you need to focus upon for that particular algorithm. And then I will also try to explain you different metrics and which metrics to be used when, because these most of the questions will be asked in these metrics and hyperparameters. So for example, they might be asked you like when to use R square, when not to use, when to use adjusted R square, what is the difference between R square and adjusted R square, when to use F2 square, when to use precision, when to use recall. All these questions will be, you will be facing all these questions when you face interviews. So you need to have good idea on that one as well. So I will try to explain one by one as we progress through the classes. So do you have any questions? I think only 38 participants are left. So if you guys have any questions, we will take questions, and then we'll start with classification algorithm tomorrow. And we try to dive in deep into the classification algorithm and understand different because I want you to first understand the models, algorithms first. Without understanding algorithms, you will not be able to understand why we are making that particular decisions, and why we are doing what we are doing for that particular algorithm in that particular way. So I will try to cover that as much as possible, and I will try to deal with the classification problem as well. And after that, we'll go with the forecasting time series problems. Then I will try to bring in deep learning algorithms and neural networks by using natural language processing for natural language processing or CNNs. And the last day, I will try to give a glimpse about what these large language models are, and what is happening with this generative AI and chat GPT or Llama or all these language models to you. So if you have any questions, please go ahead, because there are a lot of participants. Yeah, please go ahead and ask if you have any questions. Any questions, anyone? And if I have missed, I mean, if I have explained the data drift within when I was on mute, I will explain. I would like to explain the data drift as well, because that also plays a key role. So when we deploy the model and when we train the model, we might have trained the model for a certain range of data. For example, let's take car price predictions. So let's if we take a few years back, like 10 years back, in India, in general, I mean, if we take mid-level car range prices, they were up to maximum of 20 lakhs. I mean, it was in general, it was up to 2 lakhs to 20 lakhs. So in general, the price of this car used to vary up to 20 lakhs. And now, if we take the car prices, mid-level car prices are starting from 15 lakhs to 30 lakhs. So if we train a model when the car prices were ranging from 10 to 20 lakhs, and if we and using the model after 10 years, when the price range of cars was ranging between 20 to 50 lakhs, then it will not be able to make predictions on top of that data, because it hasn't seen any value beyond 20 lakhs, because all the data that we used to train the model was below 25 lakhs, and now it went beyond 25 lakh. The minimum value now is 25 lakhs. So obviously the model will not be able to make predictions. So we need to keep a continuous monitoring after we deploy the model to understand if the data that is coming now is within the range of data which was used when training the model. So we always need to continuously monitor the model for either the data drift or target drift. Here the target has drift because the target variable was drifting. Maybe in future, what happens is, like a few years back, there was no. I mean, the concept of electrical car vehicles was comparatively low, but now there was significant traction of significant models in electric vehicles as well. So now we need to add a new feature to our prediction, because this feature is new one which was not being used when we trained the model, and the way it operates and the way the data resembles is now is different when compared with few years back data. So now, if we want to use the same model to predict price range for this particular cars, but then it will not be an ideal model to make the predictions, because the model which we trained hasn't seen any data related to electric cars, but now there are electric vehicles as well. So we need to take that into impact, and now the data has drifted from only diesel and petrol to diesel, petrol, and electrical. So now we need to take into consideration this new feature as well. So we need to use that information also for us, and then use that information as well to retrain the model. So now what we do is we retrain the model on top of the new data, and then so that the model is the model now understands the new features as well, and will be in a right position to make predictions on top of this particular new data points as well. So that's one other important thing in data science. So you need to keep a constant monitoring about either the target drift or data drift. There are different techniques to understand the drifting, and then monitor the model to check if there is any drift that happened within the data or within the target, and if required, to retain the model. And one more thing I want to tell you is most of the projects which you deal with you will be in pipelines. So there will be continuous integration and continuous CI/CD pipelines. You will be continuously adding features, so you need to have idea about Git and GitHub Actions as well. It's not compulsory, but it's better if you have this one, and have some idea about how to deal with the ETL pipelines, these ETL pipelines as well, so that you can perform some of the data engineering aspects as well, so that you will be in right position to understand how well, I mean, what type of data you need and what type of transformations you need to apply on top of the data, because you know well about the data. And other thing I want to explain is about as I have some more time, let me use the time to explain you imputation techniques. So I told you. So what happens is, like, when you have null values, what happens is, like, let me. So if you have null values, your algorithm will not work effectively, because your algorithm will not be able to deal with these null values or non values within the data. So what happens is, like, when you pass that type of data, it will the algorithm will throw an error because it cannot recognize that particular value. So in order to make the algorithm to deal with that particular value, we have multiple ways. Let's say we have null values within our data. So we have multiple options. One option is to drop the data points. Like, we can drop the data points and then use the data where there are no null values. So here what happens is, like, we need to drop all these 6 rows where there's null values for these 6 rows are having null values for this horsepower. But whenever we drop data, what happens is, like, we are losing information from the data. So we never want to do we never want to lose any information. So in most of the cases, until unless the data is so excessive, like, for example, you have thousands of rows, and the number of null values are at most there are only 100 rows with null values, and the total number of data points you have is around 10,000 or 20,000, then you can then you can make a decision to drop that one. But still, I personally feel like, rather than dropping, I will go with some imputation technique, even though it's basic imputation, because at least it will try to. There might be some information which we can grab from that particular data point as well. So that's why we prefer imputation techniques. Imputation is nothing but, instead of using null value, we try to use a value which will closely resemble the data points. Let's take horsepower here. We have 6 null values here. So if you look at the data, where is the horsepower? Yeah, if you see horsepower here, most of the data points are ranging between 20 to 100, and we know that when we pick, and based upon statistics, when we use a value within this range, the chances of being that data point being here is higher when compared with using a value beyond 200. So that's what we are doing here. We are trying to calculate a mean value or median value, and then using that mean value or median value to fill that null data point, so that it will at least closely resemble the data point. I mean, the chances of that data point, that imputed value being wrong, is comparatively less when compared with using dropping the value or using some random value like 0 or some other value. So that's why what we do is we either use mean value or median value for continuous variables. And here, if you look at this particular plot, we can see that the data is not following normal distribution. And normal distribution, I guess you know, this kind of distribution is called as normal distribution, where the data is centered around mean values. But here, if you look at this one, the data is not normally distributed, and it has a tail here. That means using a mean value will take into account the outliers and will shift the value towards this right hand side. And we don't want that to use. I mean, because if you look at this value, even though total most of the data points are within this range, within the range of 70 to 100, when we use mean value, what happens is like it will come up to some value beyond 100 value, which is not an actual representation of the data. So that's why what we do is we use the median value. I hope you guys know the difference between mean and median value. So if not, I will try to give you what is mean and median in the next session. So for the time being, consider that we are using median value here because when we have outliers or when we don't have normal distribution, median value will be an actual center point of will be an better representation of actual center point of data when compared with mean. So we are using that center point of data to represent these missing values, so that that will at least closely resemble closely provide the information that resembles actual distribution of data, and will make the training of model less will impact very less, I mean, will not impact the model in model training in such a way that it will have serious detrimental effect on the model training. Or else if we use some value like 0, what happens is like it will consider that as new data point and it will use 0 as a new value. I will train the model for 0 values, and then it will use it will it will understand different, it will create a different understanding of entire distribution of data. So that's why we use mean or median. And when it comes to categorical data, we use a mode as imputation technique, because mode is nothing but frequently used value. Let's take we have number of gears as like let's say it's either auto gear or manual gear as or hybrid, three values as our categorical data, and we have missing values in this categorical data. So what happens is like when we look at the data, we found that more 70% of data is having manual, 20% of data is having hybrid, and 10% of data is having auto as gear auto as the value in that particular gear categorical data. So what we can do is like we know that if we fill a null value with manual gear, we will be right 60% of time or 70% of time. So we try to use mode value here, because even though we are wrong, we will be right 70% of the time. So that's how we try to come up with this one. Or else what we can do is, as we are having data points for other features and target variable, we use this target variable as we use this column which is having missing values as target variable, and then try to make predictions of what can be the value based upon data distribution, because in general other data points can also influence what should be the value in this particular row for this particular column. So we try to predict this one and use that value to impute this one. So ideally what we are doing is we are using a machine learning technique to predict the missing value and using that value as imputed value. In this case, what happens is like we'll be more close to actual value that should be there. So this is how we try different techniques to deal with null values, and use different techniques based upon the problem and based upon the data we have, and try to solve the problem of imputation. I think I gave kind of extensive notes here. There are other techniques as well, like in time series forecasting. What we do is we interpolate we take previous observed data, or forward filling or backward filling also to do that one. And there is another technique called multiple imputation. What happens is we try to use multiple different types of imputation, and try to observe what is happening whenever we use this particular imputation, and try to see which is giving the best which is representing the data in the best way, and use that as our technique. So you can go through this one. If you have any questions, you can come up with the questions tomorrow. We will discuss that one. And yeah, I guess you don't have any questions, and I think time is I crossed the time. So please let me know if you have any questions, and if you don't have, we can end the session now. I'll wait for 2 more minutes for your questions. If you don't have, you can drop the session.
Okay, so dear students, we are done for the day. I shared the attendance link as well in the chat box, so please mark your attendance if anybody is missed on, or the Zoom and YouTube as well. And we'll see you at it's already 9:30 as we plan to have a session from 7:30 to 9:30. It will be the same timing for next 4 days for the A&ML module. Okay. So we'll see you on tomorrow at same time. Till the time, take care of yourself and take care of your family. Bye bye. Have a nice day and